Hey guys, here is the part 5 of this video. So, endpoint to delete data. It's a router dot delete HTTP call. Same thing, ID, async function. Const ID equals get dot files dot ID. So we load the ID first, and then in the try block, let's do const del, and then let's await dot delete one. So this function deletes an object with the ID we're gonna pass in. Underscore ID underscore ID ID. Okay, and then let's say rest dot send del, the output of what we received from there, and then the catch let's do rest dot status of 500 dot send okay. Let's check this out and save this. Go back to Postman. Let's see if we could delete the country B. Okay. And then instead of update, we're gonna do delete. Headers. Let's do okay. So let's delete country B. Okay, deleted as 1. Now let's go back to all countries. We make sure country B is not in the list, so there's only country A and country C. So this API endpoint deletes the entry. Okay, let's move into the final section of the video. Let's talk about some debugging and tracing commands, which helps us understand what's actually going on underneath the hood. So Visual Studio has some debugging tools natively built in for Node. We're gonna use that and check it out. So before doing that, go to your routes, and then I'm gonna pick this point where I'm gonna select this breakpoint. What is a breakpoint? So a breakpoint is a location in your program where the execution is going to stop, and the Visual Studio is going to show you the state of the program. So this is really helpful to debug and understand the current state of the program and understand why the program is not behaving in the way you want. So this breakpoint, what I'm going to do is I'm going to place it on line 21. This is in the endpoint to view all data. So when a user sends a request to view all data, the first task it's going to have, what's going to happen is it's going to talk to the database and pull all the data and populate this query constant. And then just before it sends the response back to the user, I'm going to stop and I'm going to check what's populated in the query. Just in case if you're not seeing desired information on your response, you could set up a breakpoint, run debug, and then you could understand what's going on under the hood and make changes accordingly. This is far more efficient than console.log because you have to place console.log in multiple locations, and it kind of gets complicated, and it makes the code look a little bit messy. So this is much more efficient. You could debug the program in a single shot and understand what's going on underneath the hood. So once the breakpoint is set, click on run and start debugging. What I'm going to do is go to my Postman and go to this get call where I get all the country and COVID cases information. Click on send. This is not going to complete this get request because we set up a breakpoint. Now you see this breakpoint is highlighted, and what happens is now the variables block shows what variables are populated at this point of time just before sending the response to the user. So I'm going to click on this. This query is nothing but this query constant that we populated with the response we got from the database. I'm going to expand that. It says it's an array of length 2. It has two objects, object 0 and object 1. I think these are the two countries, country A and then the country A's information. And then let me go to the object 1 where it talks about country C and the country C information. So this takes a snapshot of the process of the program running at that point of time just before sending the response back after this query is populated, and it shows the information what is populated. So just in case if your program is not responding with the information you want, what you could do is you could set up a breakpoint, run the program, and then look at what's going on and then make changes accordingly. This is much more efficient than placing console.log because it's one single shot and then you see all the information what's happening in your program. Once you've completed with the debugging, what I'm going to do is once you understand what's going on, what's the issue, you could also do continue. So right now it's stopped in this breakpoint. You do continue, it executes the function, and then when you go back to Postman, you get the response back. So the good piece here is you understand what's going underneath. You don't have to go back and forth, make changes, and hope it works. You understand the exact state of what's happening under the hood, and then you could debug much more effectively and saves a ton of time. So once you're done with the debugging, remove the breakpoint and then click on run and then stop debugging, so you could go back, make the changes you need, and then run and test it out for desirable results. The next tool that is very useful with debugging the app is called Tcp Dump. It populates all the network calls done within your machine, and then it's easier to debug just in case if your app is not communicating with the database or the database is not responding, those kind of connection issues. So what I'm going to do here is expand this, and then I'm going to run npm run dev. Right, so this runs the application. I'm going to open up another terminal, and then what I'm going to do is I'm going to run this program called TCP Dump and listen on packets on port 3500, see what's going on under the hood, right? So what is the command? So what is the Ethernet? So IPA gives you the IP address of the machine. So this is 10.0.0.247, which is nothing but your application server. Let me go back. So 10.0.0.247, that's the application server. So I'm listening on that machine. I'm listening on that machine on port Ethernet 0 on interface Ethernet 0 on port 3500 or 27017. So this one is the port 3500 is the app that we're running on, the port that the app is running on, and 27017 is the port that is used for MongoDB. So this will show the connections coming from the Postman to the app server and from the app server to the database. So right now it's listening on that port. What I'm going to do is let me go to Postman and then send this request. It got a response. Let me cancel this, and then let me read through this, and then let's check it out. Let's check out what actually happened. This can throw in a ton of data because of the information that we received. So we already had this, so let's not look at that. So this is where it starts. So our Postman is running on this IP address 10.0.0.89, and then it sends this GET request to the app server, which is running at 10.0.0.247 and port 3500. Right. So once this is complete, what happens is the app server responds back to the postman saying it got the request, and then what the Node web application server does is, which is 10.0.0.247, talks to the database server, which is 10.0.0.246 and on port 27017, and then it sends a request to get all the country information, and then the database sends back all the information. Like, these packets are nothing but the database sending back all the country information. See this is the database server, and this is the app server. So app server gets all the information, and then comment below, the app server so this is right here. So after receiving all the information from the database, the app server sends all the information it received back to the postman. So this is how it's much more effective to troubleshoot on the network, just to make sure, just in case if your postman is sending requests, if you're not receiving any packet data back, and you see the web server running, you could run TCP dump on your web server just to see how the packet flow is happening, to check if the server is receiving packets from postman, or if it's not sending packets to the database, or it's not receiving packets from database. In that way, you could troubleshoot the network connectivity between the three pieces. So debugging helps you find issues inside your process. The TCP dump helps you figure out network issues between the three pieces: the front end, the app server, and the database. The third tool that I want to show is called strace. What strace is called? Strace is not something like a system call strace. So when Linux runs this program, it has a process number. So what we do is we trace this process number or process ID, and then we see how the process is communicating with the Linux system, and what's happening underneath with the calls, with the system calls. So let's look into the strace command. What I'm going to do is find the process ID for this node program that we are running. So I'm going to prep for node. I have a ton of them, but this is what I'm looking at. So 28814. So let me clear that, and then strace dash fp and then control V. So this shows you what's happening underneath the hood for this program. And then let me go back and send the same post call. Okay, it got a response. And then let me stop here. And then let's go back and see what happened, right? Okay, so before starting this, the epoll is the Linux it's the Linux feature which makes this non-blocking IO, the asynchronous code, to work. So that's why you'll see a lot of epoll. So here, see this except for, that is nothing but the IPv4 connection that the program, the web server, is listening on. So it gets that request, the HTTP request. Once it gets the HTTP request, what it does is it creates a socket, it creates a socket to connect to the database and receive information from the database. How do you know it's creating this socket for the database? You see this connect function, and you see the port number 27017. That's the IP address. This is the database connection. So what Node does is it uses this. It creates a TCP connection to the database, and it requests for the information. So after some time, the database gives out the information. So this is the read and write here. Those are the information it receives from the database and places it on the local memory buffer. And the write V here is the information it gives out back to the user. You see the HTTP OK and then the ID. So this one is the information it sends back to the user, which is nothing but the res.send. So by tracing this process ID, you could see underneath what the actual node program is doing and grabbing the information for you. So this is another good debug tool that you could test it out. Just in case if something is not working as desired. And this is also like a good place to test how the non-blocking on the asynchronous works. Like the accept for connection. If you receive multiple accept for connections from multiple users, because what the non-blocking IO does is it creates the socket connection and then it moves on to the next connection. It doesn't wait for the socket connection to complete and then start to accept the next connection. So what happens technically, it keeps on accepting the connections, and in the background it opens up connections to the database, and then once this information comes back, it responds to this corresponding except for the user connection and sends the information back using this callback function. So this kind of talks about how this kind of proves this is asynchronous communication. And if you run the same strace command for Python or Flask application, the IO, you will see the IO task is the response is not sent until the IO task is complete if the requests are received from multiple users. It goes sequentially. It doesn't go in an asynchronous manner. And that is all I have, guys, for this time. I hope this helped. I will post the code in GitHub and place the link on the description. I hope this helped all of you. Thank you so much.